Should start? Yeah. Okay. 안녕하세요. I'm sorry everyone, I don't speak Korean, so please bear with my English. Hello? Good morning? Good morning. So, this session is called Divide and Divide Refactoring Code in Python. I am Niño Eclarin. That's my good picture. And I'm from the Philippines. So I'm a software developer at Hackarus. It's a Japanese company. I'm also a backyard astronomer. So if you love astronomy, you can talk about anything physics with me. I love Rick and Morty, if you're watching that show. And I'm always curious. You can follow me on GitHub or in my Medium account. Let's get started. So, first one is, who knows Eagleson's law? Are you familiar with Eagleson's law? No? No one? So, basically, Eagleson's law means if you write a code today, and you go back to that code after 6 months, you don't know that it's your code. Because we often look at our codes, and then, oh, this is my code. And then after 6 months, you look at the same code, it's like, who wrote this ugly thing? So, basically, it's all related to refactoring. Because as a developer, we continuously improve our code and gradually, improve our code base so that after 6 months, we still know whose code that code is. So in this session, we're going to first define what is refactoring, and then how does it affect your code quality. And we're going to show you different refactoring approach, basically some design patterns and how to detect if your code needs to refactor, if you need to refactor your code. And then lastly, we're going to show you how to assess the results and what's the next step after you've finished refactoring your code. So, refactoring. The boring definition in Wikipedia says it's the process of restructuring your code, without altering its behavior. So this is quite boring. So I asked several of my friends, and that's their definition. So I have a fresh graduate friend, he just says refactoring is just making code pretty, And then for junior developers, it's like, it's cleaning the code of my, senior developers because senior devs doesn't want to clean their code. They just pass the task to the junior devs. And for senior devs, it's like, I don't want to clean my code because I'm a senior dev. Just let others do it. For QA, for quality assurance, they just says, hey, just don't break any test. We don't care what refactoring is, just don't break any test. And then for project managers, the org is gonna say, do we have time for refactoring? And for product owners, if you've interacted with product owners, basically they're just gonna ask you to add a new feature, no matter what you said to them. And for executives like CEOs, the high-ups, they don't know what refactoring is. Now, as a developer, our code is like Legos. When we started doing the code, it's this dirty. It's like, I don't know what that looks like. But it's working. You can still play with it. And our goal as a developers is to be able to transform our code into something like this. It's organized, it's clean, it fits together perfectly. And that is one of the goals of refactoring. So again, from this one, we're gonna go to this one. Now, how does refactoring affect code quality? First is, it makes your code more readable. It makes your code easy to maintain because a code that is not easy to maintain is basically a bad code. You're just putting the company or at least the whole project in jeopardy if your code is not easy to maintain. And then another help for refactoring is it's easy to test. Okay? So refactoring makes your code easy to test. It also makes your code to have faster integration with other components because refactoring modularizes your code. Now, do you need to refactor? Yes or no? Yes? Yes? Well, at some point. Don't rush things off. At some point you need to refactor. So, yeah, that's me, basically. When I look at my old code, it's like, what have I done? Yeah, that's right. So, all of us at some point need to refactor our code. maybe some of us have done it already. So, right here, how would you know if you need to refactor? How would you know that, hey, I need to change my code now? These are the signs. So the first sign that you need to look for is there any repeating logic in your code? So if there is a repeating logic, then maybe you need to refactor. The next sign that you need to look out for is it difficult to extend the feature? Like, for example, the other team wants to use the library that I built, and then they're having a hard time using it. So, why? Then probably your code or my code is not well structured enough for them to be able to use it. And this one is for my QA friends, because oftentimes when tests break, your code is not well structured. That's 100% sure. And lastly, which I think is for me the most important, if you have a new hire or if you have a new developers and they're having a hard time understanding and onboarding and understanding your code, then maybe it's time to refactor your code. So, what are your goals in refactoring? Our first goal in refactoring is first to improve the code quality. Again, I'm emphasizing the code quality because it allows the code to be more maintainable and it makes it easier for new people to understand your code. Next goal is the testing. It should make testing easy. And then again, it should make integrations faster and efficient. And lastly, it should make the system more modular. So you can compartmentalize everything. Now, you know when to refactor and you know what to look out for if you need to refactor. Next is, how will you know the schedule of your refactoring? First one. By the way, who among here works in startups? Startup companies? Yeah? So I think it's pretty much the same in startups and in corporate company. You need to check first with your higher-ups, whoever that is, and ask them permission if you can refactor. So check with your team leads, check with your project owners and project managers, and convince them, hey, I need to refactor this. Because if I don't refactor this, I'm going to be ashamed for all of my life. So, yeah, ask for the permission. That's the first step. And the next one, which is really important, do not refactor early. Most developers, when they see and use new technology and they start a new project, it's like, oh, I need to optimize, I need to optimize, I need to optimize. And after that, the requirements change. So all your code goes to the garbage bin. I'm sorry. Again, do not refactor too early because it will waste a lot of your time. Trust me, it's based on experience. Next one, do not refactor too late. Because after 6 months and you didn't touch that code is no longer yours. You won't understand anything that's written on it. So don't refactor like too late. Maybe 3 months after you've written the code, you can check it out. And my final tip for the scheduling is use small incremental refactoring, just little by little. Again, ask for maybe 10% of your time to do the refactoring. Now, yeah, that's Rick. So these are the refactoring approaches that I've learned throughout my entire life. And I'm gonna show them to you. Basically, these are series of code base, snippet of code, and then we're gonna try to understand how can we improve these codes. First one. This one is a Flask application. Who has been using Flask? Flask? Okay. So basically, this is very, very, very simple. As you can see, we have 3 routes. We have first route, which returns a success, and route number 2, which returns a 404, and route number 3, which returns a 500 error. Now, if you might notice, route 2 and route 3 basically does the same thing. They both return an error message. But if you look at the code, route 2 does it with an abort, while route 3 does it with a make response. So, what should I use? Should I use abort? Should I use make response? I'm not sure. If someone handles this code, and basically we're all copy-paste developers, they're just gonna copy the code and paste it somewhere. So it's gonna take a lot of mess. We're gonna deal with this later. Let's continue with the examples. The next one. For example, in this class, we have two classes. We have Rick and Morty. And then it's pretty straightforward. In both classes, we can see the show dimension method, and they're exactly the same. So mostly, if they're exactly the same, maybe we can, refactor it in such a way that we can reuse the function. We're gonna show you another example. This one right here. This one is a filter-based operation. Now, I consider this one an anti-pattern, and you will know later, because there's like magic in it. So, as you can see, there's a function. The function accepts a parameter, and depending on the type of parameter, it will return a specific kind of response. So, this is like a filter-based approach. Okay? Now, filter-based approaches like this can be converted into hash-based approach. Or you can use mappings, dictionaries, which I'm going to show you later. Now, to show you a more detailed example of this, where's my code? Now, here's my code. As you can see here, there are three classes, which is genin, tunin, and jonin. Each class has has a specific method assigned to the class. Only genin can do, only tunin can do, and only jonin can do. And all of the classes have a validate function. And the validate function is different for each classes. Now, here, we have a Flask application that uses those three classes. Based on the route, we initialize the class, and then we perform the validate function of the given class. And then after that, we perform the only action that a class can do. So, if you look at this thoroughly, you can almost see that, that's quite fishy. It's quite similar. The logic's the same, they're same in structure, then maybe we can refactor it in such a way that it only uses one route. This is also an example of a filter-based approach. I'm gonna show you the detailed examples, the detailed solution later. Now, going back to the slide, which is the last one, is about data formatting. As you can see, we have a MySQL result. So this is from a MySQL database. We have a list of ninjas. Naruto, Sakura, if you watch Naruto. So we have this, and then we have a team, and then we have their skills. Now, usually we don't return this like this. It's ugly. So, hey, let's format it. So we want to convert this into this. So it's much more beautiful to look at. Now, we have a list of members, and then there's a member count, and then there's also a member key with all the members in it. Typically, I see developers do this. So if you want to convert a list into a list of dictionary with a key, what we do is we have a temporary dictionary. I hope this code looks familiar. We declare a temporary dictionary, and then as we iterate through the list, we create a new entry in the dictionary based on the key. And after all that has been done, there's another loop, and we just append the team based on the values from the dictionary. So there's two loops. And as much as possible, we learned in programming that we need to avoid loops, because loops can cause a lot of execution time. Now, we're dealing with data, and in refactoring, it's not just about the code, it's about data. So the data structure, the ordering of data, the type of data, and the size of data affects what your code looks like. As you can see here, we have data that is not ordered. And then, right here, we have two for loop, just because the data is not ordered. I'm going to show you later how to, the solution for that. Now, let's move on to the design patterns and solutions on how to be able to use this and utilize these codes right here. Now, first is, we're running away from all the bugs, because there's bugs. No? Okay. Sorry. First, we're going to go back to the first example. First example is the Flask-based application. Problem is, Route 2 and Route 3 does the same thing, same behavior. And the solution, if you're using Flask, you might be familiar with this. We can create a custom error response class. And then, since Flask has a feature called app.errorhandler, we can catch everything into one. How does it look like? It looks something like this. So, first we declare an error response class. And then, after we declare the error response, we then invoke the app.errorHandler decorator. And we just create a response using the make response. Now, I won't go into details because the general idea that I want you to know is this. So once you have a generalized way of doing things, as you can see, route 2, you just trace an error. And this will be an error 404. And then route 3, you just trace an error. And this will be error 500. And if you have another route and another route, you can reuse the same exact function. So if you have repeating logic, then ideally you would want to combine those logic into one. And in Flask, error handling, that's how you do it. The next one is the Rick and Morty class usage. Again, it's just duplicate code. So if you're familiar with classes in Python or in OOP in general, you can create a parent class, and then the parent class, all the methods in the parent class can be inherited by the subclass. You can also use method overriding and method overloading for those who want to try advanced way on how to handle this. Now, the solution is quite simple. I created a parent class called InfoFormatter. I created a method in InfoFormatter called showDimension. And then for the class Rick and class Morty, I just use InfoFormatter as the parent class. So, that's it. I basically just separated an entire code block. And I can reuse InfoFormatter anytime I want to. Now, this one. This is a bit tricky because I'm not sure if most of you have seen this approach. Again, I said earlier that dictionary types can store lambda functions, and basically they can store anything. So instead of using if, else if, I can use dictionaries to store which kind of action is needed for a specific type of data. Like this one. So, as you can see, instead of declaring a class, instead of declaring a function, I declared and initialized a dictionary. And then, for the dictionary, depending on the key, which is string, or integer, or datetime, I assigned what kind of function will be executed. Now, why would you ask? You would ask, hey, why would we do this? Isn't it much more readable or faster if we do else if? Actually, yeah, it makes sense. But again, this is just an example, and this is just to show you that hash-based approach is still faster. Hash-based approach is O of 1. So the speed is O of 1. Now, I'm going to show you the solution for the more complex example. Earlier, again. So, again, right here, same as the example, the first one, we have 3 classes, which is the genin, tunin, and jonin. So nothing changed. But when you go down, you can see that there's just only one route instead of 3. Now the original, we have 3 routes. And then when we try to refactor it, there's only one route. And it's only possible because of that ninja map variable over there. Now, instead of doing a conditional or a conditional type of approach, which is using 3 routes, I generalize it by creating a ninja map, and then based on the key, I'm gonna return a specific class. Now, here in the route, you can see there's a variable ninja type. In most cases, like Django or Python or Flask, you can do something similar. Even if it's an function, so it's basically like a function. It accepts a parameter. Now, depending on what type of ninja, it will access the specific key, and then it will invoke the validate function of the specific class. Because again, we generalized everything. And then after that, we're also going to invoke the unique action of the class. And everything became more simple, all because of this. Now, the takeaway for this example and for the previous one is, if you can convert to a hash-based approach from an else if, or from a switch type, I suggest you use hash-based. Because it's much more easy to extend, it's much more readable, and it's a lot faster. Trust me, I've tried this in like, I think, 4 million rows of data. And it's a lot faster when you use hash-based approaches. Now, going back, let's move on to the last example, which is the MySQL example. Again, the problem is we want to convert this data format right over here to this data format right over here. Now, this is the traditional approach. We use a temp dictionary, and we iterate through the dictionary to append it to the theme. Now, one of the solutions that you need to consider when you're dealing with data is what's the code structure. What's the data structure? What's the data size? What's the data ordering? Again, this data right here, as you can see, the key is the theme. So the theme column is not ordered, right? So it's like 7, 4, 7, 2, 3. So it's not ordered. So you need to create a temp dictionary to be able to handle that unordered type of data. But assuming that the data returned from MySQL is sorted by the theme. So ignore that part because I just sorted it to simulate a MySQL sort. So assuming that the data is sorted, you have now something like this. So you removed and eliminated the for loop at the bottom. And the reason is the data is ordered. So you see the difference? Unordered data versus ordered data is a lot more faster. Because you don't need to compare a lot of stuff. You can just assume that if the key changes, then it's a new entry because it's ordered. Similar things can happen when you're processing billions of rows of data. So you cannot store them into an array. Sometimes I store the data when I'm processing data in Python, I store it in a tree, for example. I don't use arrays for storing billions of rows of data. I use heaps. Sometimes I use stack, sometimes I use queue. But I never use array. So the takeaway in this example is you need to know which kind of data structure to use, especially in Python, because it affects how you refactor your code. Now, I'm gonna show you some other examples that I'm using for refactoring. These are like just basic stuff. So I see people merging dictionary. So you can merge dictionary using unpacking. So as you can see, A, and then there's B. And then to create C dictionary, we just use unpacking, and it will result into the desired outcome. Now, another example when refactoring that is quite useful for me is adding else in for loop. So in Python, you can add an else clause after a for loop, which is quite weird, but I think it's useful. So as you can see in the first one, in the above example, I need to declare a flag to see if it's found or not. And then, in the bottom one, I just use an else. So it will execute if the for loop did not break. So if a for loop did not break, it will execute the else clause. And then lastly, what I think is quite important is, when you're refactoring, do not use map, filter, and such similar functions, because it affects your code a lot. It's slower, and it's not readable, Because coming from a JavaScript perspective, I often use map and sort, But in Python, it's better if you use list comprehensions, like, the example in the second one. Now, all of this, once you understand that the language can help you in terms of refactoring, boils down to this, the single responsibility principle. Who is familiar with the solid principles? Solid principles. No one? So I think you should search that because it's a very important part of software development. So, there's a child and then there's the parent. The parent is responsible for the child. For every action of the child, the parent will answer to it. Single responsibility principle basically states that a single function or a class or a module should only handle one responsibility. So if you have an addition function, then it will only need to do addition. That's it. The responsibility should be as small as possible. So you cannot say, hey, I have an addition function, but you can pass additional parameter to make it subtraction. So if you pass a string that says negative, then it will do subtraction. No, you cannot do that. It will break the single responsibility principle. And the reason why you shouldn't do that is the functions that you create should integrate seamlessly with one another. You will have an addition function, and then you will have a subtraction function, and a multiplication function, and when you combine all of them, then basically you can create a calculator function. So, single responsibility principle helps us compartmentalize our code properly. Now, is code refactoring worth it? Most of us will say yes. Maybe. How would we know? Measuring effectivity in terms of refactoring, just look back at your goals. So, our goal is to improve code quality. When you look at your code, did it improve? Is it more readable? When you ask the new developers to read the code, can they read it? If you ask the QA to test the code, can they test it properly? Is the test not breaking? So, is it easier to integrate? If I ask someone to integrate with my code, is it easier for them to integrate? And is the overall system more modular? If I want to replace something, is it easy to replace? So, these are the stuff that you need to ask yourself when you want to measure if the effectivity of your refactoring is good or not. And then, the most important thing is you need to show off. You need to brag about what you did. You need to organize. Ask your team leaders, organize a simple brown bag session to be able to show, hey, we did this, we did that. Because in a company, it's important to show improvements. It's important to acknowledge people who does, really good things in terms of maintaining their code. It's also important to do not forget to document the changes. Because if you did everything and it's not documented, basically it didn't happen. That's how a company goes. And then, create benchmarks. There are a lot of libraries like this one, PyPerformance, which can create benchmarks and give you quantitative data if your code really did improve. We have coveralls for code coverages. And you can have continuous integration, check if the code quality improved. There are a lot of tools like this, like Travis. There's also one in Jenkins. Again, I've mentioned earlier, ask your PM and leads to inform the higher managers about what happened so that they can recognize you. And lastly, if you created a new library, don't forget to tell to other developers, hey, I created a new library, maybe you can use it. Because it's going to probably help you improve the library out of all the refactoring that you've done. Now, right here, as you can see, is the one that I've been working on in my one of my projects I've been working on. When I started, there's a lot of code base, but it actually just boils down to these components right here. So we have a data processing component, and we have a mobile API, and then several hours setup plus the mobile, and that's it. That's the whole system. And it's like several thousand lines of code. So after 4 months of continuous refactoring, continuous improvement, it became like this. So I know it's a bit messy, my drawing skills are not good, but as you can see, I've created several microservices and libraries out of this puny little thing, and I'm able to separate them and make them talk to each other seamlessly. I did not do this in just 1 day, in 1 week, no. I spent 4 months. Refactoring is a continuous process. And, going forward, I would advise that when you're having difficulty in terms of maintaining your code, you need to have a regular code assessment. You need to dedicate a time, at least once a month. Talk to your project leads, talk to your managers. Hey, can you give me some time, please? I'm gonna treat you some Starbucks. Just give me some time. And then make sure that the leads and the managers understand that it's important to refactor your code. Tell them that, hey, if we didn't refactor this code, we're gonna lose $20 million. And I'm quite sure they're gonna, they're gonna allow you to refactor the code if they're talking about, if you're talking about money. Early refactoring is a waste of time, remember that. And refactoring too late, it incurs a lot of technical debt. Lastly, as I've shown, you can use language features to aid in your refactoring. So Python is a robust language. It allows you to do a lot of stuff. Use that. Leverage on it. And lastly, I write regular stuff once a month. You can follow my Medium right there. All the code examples will be at this link. So I've added other several examples that you can use and that you can see. There's a lot of it, so check it out. And if you're interested in AI and in healthcare, you can check us out at Hackaros. We're basically doing machine learning and data processing and all of those cool stuff, but we're using sparse modeling. We don't need a lot of data. It's just, just even one data, it can work. So check us out at Hackaros. You'll learn more about sparse modeling. That's a great way to do data processing. And happy refactoring, everyone. So if you have questions, you can ask me now. Thank you.